Hey statisticians, in a previous video, we were just talking about errors that can occur in significance testing, and we classified them in one of two ways. We talked about a type 1 error, which occurs when we reject the null hypothesis, though the null hypothesis is true, right? And another situation where we fail to reject the null hypothesis, but the alternative hypothesis was in fact true, and therefore the null hypothesis was false, right? And we talked about how the probability of a type 1 error is called alpha, and the probability of a type 2 error is called beta. I wanted to look at just another quick, more statistical example that you might encounter, say, in tests and junk like that when we're thinking about what we're doing here in our particular course. So let's look at this example. Here we see the manager of a fast food restaurant wants to reduce P equals the proportion of drive-through customers who have to wait longer than 2 minutes to receive their food after their order is placed. I mean, I don't know. I go shopping. I've gone to Chick-fil-A and waited, gosh darn, longer than 2 minutes for my stinking food. Gosh darn, their chicken sandwiches are good though. Oh, it kills me. But yeah, so they want to reduce the wait time for customers. And they want to reduce the proportion. Really key here is the proportion of customers who have to wait. Based on store records, the proportion of customers who have to wait longer than 2 minutes is about 60%. If this was Chick-fil-A, it'd be like 100%. To reduce this proportion, the manager assigns an additional employee to assist with drive-through orders. And apparently they're going to actually see if it makes a difference. And so for us, if we were thinking this statistically, we're going to say, is there significant evidence that having this additional employee actually leads to the result that we're looking for? Our null hypothesis will be that things are still the way they used to be, right? So we'll make the null hypothesis that P is 0.6, that the proportion of people who have to wait is just the same as it was before. In fact, I'll make that a nicer color there. Good. Now, if I'm talking about the alternative hypothesis, the alternative will be that this method was effective. Remember, the goal was to reduce the proportion. So I'll say that the alternative hypothesis is now that P is less than 0.6. So look at that. It's a little terrible handwriting, right? And so, all right, now we're not actually carrying out a test and we're not going to calculate a p-value here. Here I just want to reflect briefly about what kind of alpha should we select. And really thinking about what kind of alpha we should select, we're really thinking about what would be the type 1 error here and what would be a type 2 error. And which should we be more worried about? And what would be the consequences of these types of errors, right? Well, remember, the type 1 error would be the situation where I would reject the null hypothesis when the null hypothesis is true. Let's think what that would mean. In this particular instance, if I choose to reject HO, right, then that equals that the employee helped reduce reduce the proportion of customers who had to wait a really long time. And so that would be my conclusion. I'm rejecting the null hypothesis. But if we're saying the null hypothesis is in fact true, to say that HO is true is to say that the proportion remained the same. And so if we think about this, what does this mean in a type 1 error here? Is this a terrible situation? So we think that the employee actually helped reduce the situation when they didn't, right? What's the consequence of that? Well, we think we've solved the problem by assigning this employee to this role, but we actually haven't solved the problem. So we think we've solved the problem, though we haven't, right? Customers are actually still waiting the same amount of time, and we think we're wasting our money potentially having this employee trying to assist with the orders, and nothing has really changed. That would be a type 1 error. What would be a type 2 error here? Well, in a type 2, recall, right? Let's go back to the definition. In a type 2, we fail to reject the null hypothesis when the null hypothesis is false, right? So if we fail to reject, these markers are kind of thick. It's a little difficult to read, and I apologize about that. If we fail to reject the null hypothesis, this means we think that the employee made no difference. Employee made no difference. That says no diff, right? But the alternative is true. This would be an error here. Remember, this is an error. The employee made no difference, but the alternative is true. This would mean that the proportion is reduced, right? We really did reduce the proportion the way we were looking for here, right? And so here, what's the consequence of this situation? Well, the employee actually, wait, hold on. I said to fail to reject the null hypothesis means that we conclude that the employee did not make a difference when in fact the employee did. Oh, I'm going to confuse myself there for a second, right? So to fail to reject, so we think the employee did not solve the problem when the employee did. When the employee did. Assigning that employee there actually did solve the problem. So here we had this problem we tried to identify. We thought of a way to fix it. We employed that method and it actually did fix the problem. But then at the end of the day, we concluded that it didn't. So what's the consequence here? Well, the consequence of a type 2 error here is that the problem continues to exist and we try to find a new solution, additional solution to the problem when in fact we had already found one. We're wasting our time. If only we just trusted that this employee made a difference, then we would have realized our problem is fixed just by reassigning. In a type 1 error, remember what was the error? We thought we had solved the problem, but we haven't, right? So we had this employee trying to do the job. We would continue to pay them and potentially wasting money, but the problem still persisted, right? So which is the worst error in this situation? It's a tough call because there's consequences, and either way you still have the problem sort of persisting. You haven't fixed it. In this situation, you're looking for a new solution when you already had one. In this case, you think you have a solution when in fact you don't. For me, I would think that it's I don't know, which would I decide? I think making the type 1 error maybe is a little bit worse, because if you think you've already solved the problem but you haven't, then that's not so good. So I'd probably make my alpha maybe point. I don't know if I'd really make alpha 0.01. Maybe that's a little extreme. I'd probably just settle with our good old standard alpha here at 0.05. Though I'd err on the side of something slightly lower because I don't want to think I've solved the problem when I actually haven't. But you know what? Maybe I just want something down the middle, like a good old standard 0.05. I'd have to really reflect on that. But of course, this is just a fictitious example. If I was really a boss here, I would have a lot more on the line, and maybe it would mean more to me. So I hope this example of thinking about type 1 and type 2 errors was helpful. Remember, once again, the type 1 error is that you reject the null hypothesis when the null hypothesis is true. And the type 2 error is when you fail to reject the null hypothesis, the alternative hypothesis is true, right? You got to get those definitions down. Thank you guys. Have a beautiful day, and I'll see you on the flip side. Giddy the heck up.